Hi everyone, let's solve an interesting Leetcode problem, valid Sudoku. So this game is very interesting because essentially it can help the player of this game immediately knows whether they're making the right move or not. So suppose we have a 9 by 9 Sudoku board number represented as a matrix. So essentially it's a list of the list. And what we want to do is to check whether a failed cell fulfills the following rules. The rules are defined as the following. Each row must contain the digits 1 to 9 without repetition, and similarly for each column and also the 3 by 3 sub-boxes. So as you can see here from the example, let's say what number can be filled under this cell. So we see there are already 3, 5, 7 in this row and also number 8 in this column. Also number 6 and 9 in this sub-box. So the numbers that can be filled here should be either 1 or 2. So in other words, if there's another 3 or 5 here, our algorithm should return false. But in other case, this should be a valid Sudoku board number that the user can proceed with again. So let's write out the algorithm for this problem. So basically, we want to search for each row, column, and also sub-box. Also, another thing that we should define and think about in our algorithm is how to actually check each row, column, or the array does not have the repetition. So there's some different ways that we can check whether the array has a duplicate number or not. So one way is we can define another variable that could be either a hash map or a set. And while we are looping through each element in the array, we can check whether we have seen that number or not by storing the searched number in that hash map or the set. But this is maybe not the most efficient way to do that. So another way is that we can easily just check the length of the array versus the length of the set of that array. So what does that mean? So it means if we have an array 5, 3, 7, it has a length of 3, and the set of that array will be the same because there's no repetition here. So the length should also be the 3, and that's good. However, let's say it is 5, 3, 3, 7, and then the set will be 5, 3, 7. The set, if it has a repetition, the length of the set will definitely be smaller than the length of that original array. So in that case, we know immediately that that array has a repetition number in there, and we should return false. So say we use length of the array and set of that array itself to check for repetition. Okay, let's first write down the first row to check for each row. So here is already we know it's a 9 by 9, so we'll have this board will has 9 rows and also 9 columns. So for I range 9. So let's say suppose it's an n by n matrix, so either we can just put n here. So we want to know the element for each row. So we can use less computation to easily grab that number here. And also we want the final array only to contain the integer digits and ignore the dot values, which represent the empty cell. So we can do the integer I for I in board I only if it is not equal to the dot. So here under first iteration, we would have 5, 3, 7. and then we check for whether it has a duplicate or not. So we can do whether the length of that array is equal. So we are checking whether it is not having the same length. And if that's the case, we should return false. Basically, we do not need to check for the other rules if we already find a duplicate element for one of the rows here. So it has a early stop. And then we check for the column. So similarly, it also has 9 columns. And to grab the number for the column is a little bit tricky here, because instead of just it's a list of lists, so essentially we are looking the element at different rows, but at the fixed same column index for each iteration. But similarly, we can use the list computation in order to achieve that. So it will be the integer number for the board element at index I and j. So at each iteration, j is fixed, and for I, we need to iterate through 0 to 8. So essentially, we want to get that for each row. And also similarly, we don't want the top value in our final array. So we want to filter out that not equals to dot. So once we have that, similarly, we do the checking the length. If it is not equals to the length of the set of the column, and then we return false. Okay, now here we have written out the second row. And how about the final rule for each sub box? So here, essentially on a 9x9 Sudoku board, it will also have the 9 3x3 sub boxes. So you can see the boundary for each box is actually board value here, so you can easily see what is defined as a sub box from the example. So the first box is basically 5, 3, 6, 9, 8, and then iterate through the other ones. So one observation here is that for each box value, we can think about what is the row and also the column index for the numbers in that sub box. So for example, 5, the index is 0 and 0. And then for the second box, if we are moving to the right, here should be the index should be similarly the first row is also 0, and the column index would be the 3. And here the row index would be 3, and the column index should be 0. So essentially, we know it will always start with the index by 0, 3, or 6. And for the remaining values, essentially would be going to the down and also going to the right by 2 indexes in order to fill that sub box. So given that observation, we can also very easily grab the sub box array from this big matrix. So in the range, so essentially each box is incremented by 3 index, 9, 3. So this way we are just basically getting 0, 3, and 6. And also for J in the range of similar 9, 0, 3, and 6. And we want to get the array for that subbox. So that would also be, so similarly, we should also use this comprehension and also the looping to some incremental indexes in order to get all the elements in that box. So here it will be for m in the range of I and I plus 3. Because for the first box, the index will be from 0 to 2, and also similar for the column 0 to 2. And we want all the mutation of these indexes. In the range of j plus 3. So here is already long, so let's write the filter in another row here. So we also want only the digits here. For I in box, if I is not the dot value. Similar as before, we can check the length of this array and also this set. Now equals to was. Here, something is missing here. A range if a number is not equal to 2. Let's check this row again. So integer for the value for I. Yeah, we're missing the I range. Okay, so when the algorithm runs for each row, each row here, once it finds a repetitive number, and will stop the algorithm. And if it has run through all these rows here and if they're not returning false, then we should return true. That means the current Sudoku board is valid and the user can proceed with playing the game. So let's run it. And it has two sample test cases. So another thing we should think about is about the time complexity for this one. So essentially we are having the 3 loops here, and each loop, essentially we are searching through all the elements here. So in other words, for each iteration, we are searching for 9 plus 9 times 3 elements in total. However, this is still a constant number, so the time complexity should be still all 1. But in other case, if we are say searching for through n by n Sudoku board, then the time complexity was similar to O n power, because we are dealing with a larger Sudoku board and it can be pretty complex. And so let's submit our algorithm to see how it runs. Yeah, we see it passed and beats a lot of other users with the Python solution. Thank you very much for listening.